All right. Today we are going to have a look at principle of flotation, which has already been stated in one of the previous videos, but we have not had any calculation on it. But as a reminder, it is restated here. The principle of flotation states that a body floats in a fluid when the weight of the fluid displaced is equal to its own weight submerged. So you can see this is quite different from Archimedes' principle, because this time around the weight of the body that is immersed will be equal to the weight of fluid displaced, whereas Archimedes' principle did not tell us that the weight of the fluid displaced will be equal to the weight of the body submerged. No. So, but in this case, principle of flotation, weight of body submerged equal to the weight of fluid displaced. And weight of fluid displaced is the same thing as upthrust, which the fluid will have on that body. And upthrust is density times volume times G, where density is the density of the fluid. The volume is the volume of the body that is submerged in it, because it will have the same volume as we had it also in Archimedes' principle, and G is a constant. So you have to take note of this. So as we are going to have a look at an example question, we are going to apply this information. All right. A plastic sphere flows in water when 50% of its volume, 50% means 50 over 100, which will give us 0.5. That's the volume of the plastic that is submerged in water. And 40% of that same plastic is submerged in glycerin, which is 0.4. 40% is 0.4. We are given the density of water to be this. The question is asking us to find the density of what? Of the glycerin. How do we go about this? It's very fine. Since we have volume of the plastic submerged in water, and we have the volume of that same plastic submerged in glycerin, let us use this new information to find the relative density of glycerin using volume of body in glycerin over volume of body in water. If you check one of my previous videos where I gave the list of all the formulae that can be used for relative density, that should be the last formula I mentioned. Okay? All right. Applying the formula for that relative density of glycerin, that would be 0.4 over 0.5, which will give us 0.8. So since this is the relative density of glycerin, it is now that we'll use to find the density of glycerin we are looking for by using another formula of relative density, which says density of the body over density of water. So applying this now, relative density of glycerin we got is 0.8. That will be 0.8 equals to, let X be the density of glycerin over 1000, which is the density of water. When you cross multiply, X will be equal to 0.8 times 1000. So that will be equals to 800 kilogram per meter cube. So that's the density of the glycerin.